Right. Hello, my name is Gail. Our group has chosen pancreatic cancer for this project with the treatment choice of Benzegri. So for this project, I will be discussing the biology of this cancer and how Benzegri works. So Benzegri is mainly for the subtype of pancreatic cancer called NRG1 positive pancreatic adenocarcinoma. So, something important to note about the pancreas before we get into that is that we have a endocrine section that is secreting hormones into blood vessels, and we have an exocrine section that is secreting digestive enzymes into our pancreatic ducts. These ducts and ductile cells are where this cancer is mainly going to attach itself and grow before it is metastasized. So these ductile cells are just located within the tubes of these ducts, carrying out all those digestive enzymes from the pancreas. Some molecular features of this cancer, starting with the NRG1 gene fusion. So a typical NRG1 gene is going to produce ligands that are going to act as a growth factor and bind themselves to RTKs or receptor tyrosine kinase receptors and signal downstream for cell growth, cell proliferation, etc. The difference with this cancer is that this NRG1 gene is going to fuse with a partner gene such as CD74, ATP1B1, and once it's fused, it binds into this extracellular matrix here of the cell, typically around this RTK, and it's going to uncontrollably put off these fusion ligands that are going to keep this constant downstream signaling and causing this uncontrolled cell proliferation. So that is one of the main differences between the NRG1 fusion versus a normal function of the NRG1 gene. That's typically only releasing ligands when it's told to. Another important thing to note is the KRAS gene. So within a cancer, we could have a KRAS mutant, and this KRAS mutant is going to be controlled mainly by mutation. So that's mutation is what is going to allow the cell to have this downstream signaling and the cell growth be activated. But for this cancer, we have the KRAS wild type, and this KRAS wild type is mainly dependent upon RTK receptors, meaning without these receptors being present for cell signaling, we're not going to have any cell growth or cell survival. So the signaling pathway for NRG1 positive tumors, we have, like I mentioned before, that NRG1 gene fusion occurring here, and that is going to be putting off those NRG1 fusion ligands. And what these ligands are going to do is bind to this HER3 receptor. And once this HER3 receptor has that ligand, it is going to heterodimerize with the HER2 receptor. So these RTK receptors heterodimerize, they become one big subunit. And this subunit is what is going to be putting off that downstream signaling to tell the cell to proliferate and survive. So how are these tumor suppressors affected with this cancer? This TP53 gene is producing our tumor suppressor P53, and P53 is going to be sent out whenever there is a cellular stress like DNA damage or cancer signaling. And what P53 will do is either activate cell cycle arrest using P21, so it will stop the cell whenever it is damaged at the G1S phase and force it to either be repaired using DNA repair mechanisms like the repair genes of GAD45, P53R2. And these repair genes will fix whatever needs to be done, whether it's DNA breaks or missing nucleotides. And then the cell, once it's repaired, can continue to proliferate. But if the DNA is beyond repair, then p53 could also activate apoptosis using cyclin-dependent kinases and induce cell death. So that's why p53 is like our guardian of the genome, because it is protecting that DNA from uncontrolled dividing of broken or mutated DNA strands. Another thing to note is over in this graph on the right, we have senescence, which is another pathway that p53 can activate, where the cell will just be put into a permanent state of rest, but it will still be kept alive. So what impact does a mutation on that TP53 gene have? If a mutation occurs, we could have loss of cell cycle control. So without p53 being produced by TP53, it's not going to stimulate p21 to stop the cell and have it fix itself or induce apoptosis. So that broken DNA will continue to proliferate. We could gain genomic instability this way as well, losing that MDM2 regulation of p53. So MDM2 in a normal cell is going to be a regulator of p53, because when p53 accumulates in the cell is when that cell cycle stops at the G1S phase. And if we lose that regulator and p53 is not able to accumulate anymore and is just constantly being degraded by this MDM2, then the cell won't be able to stop whenever it's broken and just continue to divide. And that goes along with no control of GAD45, again, because we don't have enough p53 to activate it. We can have apoptosis resistance or drug resistance. So p53 is not signaling for our pro-apoptotic proteins like Bax or Puma. And we can have failure of senescence. So p53 is not activating the cell to go into senescence and is instead dividing with all of these oncogenetic signals way past its normal limit and causing a higher increased risk of cancer forming. So some of the hallmarks that is affecting is evading growth suppressors, resistance of cell death, genomic instability, and enabling that replicative immortality. So how does Benzegri work? What Benzegri is a bispecific antibody that is lab created, and its main goal is to be able to attach itself to two antigens at the same time. So Benzegri's patient population is primarily focused on NRG1 positive metastatic pancreatic adenocarcinoma. So metastatic being important because we want a treatment for a patient that has already had this NRG1 positive cancer spread without affecting its normal cells being able to target those cancer cells. So what it does, over on the right, we have our regular NRG1 pathway that we mentioned before, and right beside it, we have the pathway with Benzegri. So what Benzegri is doing is attaching itself to HER2 and HER3 at the same time, because it is a bispecific antibody. And that is blocking those NRG ligand fusion ligands that are uncontrollably being put off from binding to HER3. So in doing so, HER3 is not taking in that ligand. It will not heterodimerize with HER2. So there's no signal being sent downstream to tell that cell to grow. It's going to reduce that cell growth and the cell's survival for the cancer. So what hallmarks is Benzegri having an impact on? We have the sustained proliferative signaling. So it is keeping that cell from ever even having that downstream signal received, because those NRG1 fusion ligands aren't even allowed to bind with HER3. So it's stopping that upstream signaling before it can ever pass down and tell the cell to proliferate. We are also affecting evading growth suppression because of, again, those RTK signaling being neutralized because benzagerie is acting as a physical block. We have immune-mediated killing because of that ADCC process where the excuse me, where the drug itself has an Fc binding site, it is able to find our natural killer cells. And when it does this, it is going to bind to the Fc site or the receptor on the natural killer cells and actually tell these cells, hey, the cell isn't supposed to be here. We need to induce apoptosis. So it is bringing in our immune system to actually attack the cancer cells while being a physical block on the cell itself. And lastly, we have that oncogene addiction where these tumors are reliant on that HER2 and HER3 heterodimerization pathway. So if we cut off its pathway, it has no way to continue to divide and survive.
Covering the epidemiology portion of pancreatic cancer. According to the National Cancer Institute Surveillance, Epidemiology, and End Results Program, also known as SEER, the age-adjusted incidence rate of pancreatic cancer based on 2018 to 2022 cases was 13.8 per 100,000 men and women, and the mortality rate was 11.3 per 100,000 men and women per year. For a person and variation of pancreatic cancer, the age-stratified analysis in the article found that those over the age of 65 showed the highest trend of incidence, which was 31.9 per 100,000. In the U.S., the average annual growth of pancreatic cancer incidence among men was 1.3% per 10,000 and 0.9 per 10,000, and is predicted to increase gradually in the analysis. The average age standardized rate, also known as ASRs, of pancreatic cancer incidence and mortalities of regions globally were highest in Eastern Europe, followed by Western Europe and Northern America. For the time, the incidence of pancreatic cancer in the U.S. was 12.1 per 100,000 in 2010, and is predicted to increase to 15.1 and 18.6 per 100,000 by years 2030 and 2050. This would mean the annual growth would be 1.1%. The graph on the left is SEER's data on the rate of new cases and death rates of pancreatic cancer starting in 1992 to 2023. The estimated number of new cases in 2025 is 67,440 and 51,980 for an estimated death in 2025. There is a long list of risk factors of pancreatic cancer, as there are for many other diseases. The non-modifiable risk factors this article found was age, gender, ethnicity, family history, and genetics. And then the modifiable risk factors was smoking, alcohol, dietary factors, pancreatitis, obesity. And so smoking has the strongest positive association with the risk of developing pancreatic cancer. The researchers found that due to smoking, the estimated prevalence was about 30% globally, and the risk of pancreatic cancer was doubled in smokers. Due to the overall burden of this cancer, it would be reduced if smoking was eliminated. Patients with pancreatic cancer who smoked prior to diagnosis had a 40% increased hazard for death compared to non-smokers and former smokers who also experienced similar outcomes as non-smokers. So you should quit while you can. The graph to the left shows a sex-specific trend in age-adjusted pancreatic cancer rates of 100,000 per 100,000 people among white, black, and Hispanic adults over 55 from years 1999 to 2019. In an intervention study testing the efficiency of zincotumab, 204 patients with 12 various cancer types, including pancreatic cancer with NRG1 fusions, were created with zinocutuzumab. Researchers found to see how many patients cancers had an objective response. The results found that the time to response was 1.8 months, and the duration of response, which is the time the cancer stayed under control, was 15 out of 36 patients with pancreatic cancer had a response. 42% had a 90. There was a confidence interval of 25 to 59. Observed side effects included diarrhea, fatigue, and nausea. One patient discontinued treatment due to a drug toxic effect. These symptoms are considered to have a mild toxicity. So the cost of Benagiri is quite high. The estimated price is 23,000 plus, and the price varies based on patient circumstances. But the researchers argue that it is worth it, since 29% of 93 patients had with non-small cell lung cancer had a response, and again, 42% out of 36 people with pancreatic cancer had a response. The progression-free survival, which is how long patients lived without their cancer worsening, had a confidence interval of 5.5 to 9.1 for the overall group, and the confidence interval of 5.5 to 11.2 for pancreatic cancer patients.
Hello, my name is Victor Kobe, and today I'm going to be talking about the clinical cancer research. So when we're talking about a pancreatic adenocarcinoma, it's usually diagnosed in the late stages. And this is due to the symptoms that show themselves in the early stages, which are generally fatigue and indigestion, things that are often overlooked. So by the time the symptoms increase and you start seeing things like abdominal pain and weight loss, by that point, patients are already pretty progressive with the disease. And it has a metastatic 5-year survival rate of about 3%. Spreads to the liver and lungs usually. And so overall, this is a pretty aggressive form of cancer. When we're specifically talking about our NRG1 fusion subgroup, it accounts for about 1% of pancreatic adenocarcinomas. And this specific fusion subgroup is more resistant to standard chemotherapy. So before Bizengri came out, we didn't really have any options for patients with this NRG1 fusion subgroup. We had FOLFIRINOX and some other chemotherapy-based treatments. However, they usually had pretty bad side effects: weight loss, fatigue, neuropathy, just overall declining quality of life. And sometimes they didn't even help that much. We saw it was seen about a 10% rate of slowing down the tumor, which usually isn't great. We want to see a little bit higher than that. So, and at that point, there had been no targeted therapies at all that specifically targeted this NRG1 fusion pancreatic cancer. That's until Bizengri came along, which was approved by the FDA in December 4th of 2024. It's the first systemic therapy for advanced pancreatic adenocarcinoma. And this is big because for these patients who have this subgroup and this more aggressive subgroup, this is big because it allows them to have a treatment option that's specific for their type of cancer. But it has to get tested. So 158 patients were evaluated, and the overall response was 30%. And earlier I said it was about 10% with the therapies that were available beforehand. So this is a pretty big increase in the response rate of these tumors. So we're seeing a higher response rate than was seen beforehand. And the median duration response was 11.1 months, and the median progression-free survival rate was 6.8 months. And overall, this is a good thing. Mostly grade 1 to 2 adverse effects. So nausea, diarrhea, fatigue, not great, but when you're talking about cancer treatments, those kinds of things are expected and are serviceable for practitioners. So the dose is about recommended is about 750 milligrams in IV every 2 weeks. So why are we specifically targeting these NRG1 fusions? So as I alluded to earlier, these NRG1 fusions are associated with a very high rate of metastases when compared to something like a KRAS plus tumor, as well as 10 times increased likelihood of intra and extrathoracic metastases. So these gene fusions are very aggressive, and we see a lot more metastases coming from these. But they're also rare. I said the 1% statistic earlier, and they have a poor prognosis. So patients who have this type of cancer are usually left with not very many options. So I pulled in a quote from Alyssa Schramm, MD of Memorial Sloan Kettering Cancer Center. She said, This is a patient population that has a very high unmet need. This approval gives patients who have very few effective therapeutic option a new treatment option," which kind of just goes to highlight how important that this medication is for these patients with this NRG1 fusion. This therapy is rational because, as I said before, we didn't really have anything for people with NRG1 the subgroup fusions. So the minor adverse reactions, the fact that the patient population was very much in need of this, and we were seeing a very high increase rate of progression-free results. Overall, this was a workable treatment option for people with this type of cancer. So I have some citations here, and thank you for watching.